All right, if you're in here now, I found a way that I can easily take attendance without having you type something in the chat. So as long as you are still here at the end of this, all 13, 12 of you, plus me, we'll get the full credit for this. Otherwise, everybody else will have to watch this recording. And if you are watching the recording, make sure that, again, you take all the notes. All these examples up here are something that you need to have in your notes if you are watching the recording. So without further ado, let's go ahead and all right, let's get started. So today we're going to be talking about solving 1- and 2-step equations. So we talked about like all of these properties of real numbers the other day, and that's just building up to now we know the reasoning for why we're allowed to do what we're doing here in terms of like moving numbers around, rearranging things when we're solving these equations, okay? So this is something that you've definitely done in Algebra 1 before. Shouldn't be anything like really new. But the example problems, I'm sure you can notice here, there's some decimals in here. Maybe there's some like division, there's multiplying by fractions. How do you undo that? I want to go over all those examples to really give you like a reminder. So really specifically, make sure that you take notes on all the examples. And then if some of the stuff up top is like new for you, take notes on that as well, okay? So if we're thinking about inverse operations, whenever you're solving an equation, you have to work backwards to get the variable by itself, okay? So there's 4 main inverse operations that we're going to use, and they're addition, subtraction, multiplication, and division. So the inverse of addition is subtraction, makes sense, okay? The inverse of subtraction is addition. The inverse of division is multiplication. The inverse of multiplication is division. So if we're looking at this first example up here, first example on the far side with addition, x plus 2 equals 4. We would subtract 2 from both sides. So you would do minus 2, and you would get x equals positive 2. Just subtract 2 from both sides. Now, I want you to understand that this is the same exact problem. And remember, we have the commutative property, which says that a plus b equals b plus a. Remember that from last week? Again, we're kind of building up here. So if we had x plus 2, remember, that's the same thing as 2 plus x. So for this equation here, where we have 2 plus x equals 4, it's the same exact thing as when we had x plus 2 equals 4. We still have to subtract 2 from both sides, and you get x equals 2, okay? So again, remember, the commutative property says order doesn't matter. So if you have a number plus another number, really, when we're talking about inverse operations, we're just looking at the sign on that number. This is positive, and we need to use subtraction to get rid of it, okay? So that was the first part. Now, same thing with subtraction. So if you had x minus 2 equals 4, then the way you would solve that is by adding 2 on both sides. So you add 2 on both sides, plus 2, and we would get x equals 6, okay? Now, remember, that's the exact same thing. So x minus 2 is the same thing as negative 2 plus x, okay, the commutative property. So if we had negative 2 plus x equals 4, we would do the exact same thing as what we would do if we had x minus 2 equals 4. Add 2 on this side, add 2 on this side, x equals 6, okay? So I think that's the one thing, if you understand inverse operations, that's great, but that's the one thing that could sometimes trip people up, is if you have the variable as like a positive number and you have some number first. So commutative property allows us to not really have to think about that. Okay, so then the only other thing that I think maybe could trip you up. So if we're talking about multiplication, obviously the inverse of multiplication is division. So if we had 2x equals 4, we divide by 2 on both sides, these 2 divided by 2 is just 1. 1 times x is just x. So those cancel out. And then 4 divided by 2 would be 2. Okay. So the only thing that I kind of wanted to take a note on there, if we had negative 2x equals 4, we have to divide by whatever this term is, including the sign. So if we had negative 2 times x equals 4, we divide both sides by negative 2, divide by negative 2. That would cancel that out. So we have a positive x. But now on the other side, 4 divided by negative 2 would be negative 2. So just pay attention to the sign when it comes to multiplication. When you're dividing both sides to cancel it out, you have to also divide by whatever the sign is. Okay? All right, now the division, this is, I don't know. I mean, you probably learned this in Algebra 1, but if you think about division, the inverse of division is multiplication, but that's not always super easy to see, okay? So what I want you to think of, when you have a fraction, you need to multiply by the reciprocal. If you multiply by the reciprocal, that will undo that fraction, okay? So the great example, if you just have x over 2 equals 4, okay? So the reciprocal of 1 over 2 is just 2 over 1, or you can think the opposite of division is multiplication. So I'm going to multiply by 2 on this side, and 2 times x over 2, well, these will cancel out, and that would just leave me with an x. On the other side, 4 times 2 would be 8, okay? So that's easy to see, but like the next example I had, you had negative 3 over 2 x equals 4. That's a little bit harder. And like I said, when you're dealing with these fractions, you just multiply by the reciprocal. So the reciprocal of negative 3 over 2 would be negative 2 over 3. So if we multiply this side by negative 2 over 3, these will cancel, and we'll just be left with an x, which means that then we need to multiply this side by negative 2 over 3, okay? And if you remember, when you're multiplying fractions, you multiply straight across. So we'd have 4 times negative 2, which would be negative 8, and then 1 times 3, which would just be 3. So this one would be negative 8 over 3. You see that, negative 8 over 3, okay? So again, if you just have the variable divided by a number, well then just multiply by that whole number. Super easy, okay? If you have a fraction, then you need to multiply by the reciprocal. So if we had 3 over 2x, then we would need to multiply by 2 over 3. Or if it was negative 3 over 2, we need to multiply by negative 2 over 3. And then if you do that to one side, then you have to do it to the other side, and that's how we get our solution. Okay? So I'll give you a second to get that all written down. If you have any questions, go ahead and post those privately in the chat. And then we will move to the example problems. Cool. Doesn't look like we have any questions. So we'll move to example number 1. All right, for example number 1, we have a decimal. We have x minus 4.57 equals 9.94. Okay, so I know that this isn't a super, just straightforward, easy problem because we have decimals here, but you treat decimals the same thing you would do if you had whole numbers or integers. So if we have x minus 4.57, that means we need to add 4.57. If you add that to one side, then on the other side of the equal sign, you also need to add 4.57. If we do it on one side, we've got to do it on the other side. So this cancels out over here. So the only thing we have left is x. And then when we do 9.94 plus 4.57, we get 14.51. okay? So even if you have decimals, our inverse operations still apply. We had minus, oops, I can't. Sorry about that. I don't know what's going on with my video. Oh, there we go. All right, I think we're back. Whew. Okay. Are we good? Can you give me a thumbs up if you can see the board? Okay. Yep. Okay. All right. Cool. All right. Sorry about that. I don't know what happened. All right. So first example problem. Good with that? Cool. Okay. Let's go on to the second example problem. The second example problem, we're going to go so down first, and then we'll go over. So the second one we're going to look at is 42 equals 6/7y. So remember, like I said, if you have a fraction, we want to undo that fraction. We need to multiply by the reciprocal, okay? So in this case here, we're going to multiply by 7/6. And if we do that, these will cancel out. So all we'll have left over here is y. And if we multiply by 7/6 on one side, we've got to do it on the other side as well. So we'll multiply by 7/6. Okay. Now this is 42/1 times 7/6. So I think it would be easier to probably just do that in the calculator. 42 times 7 is a very, very large number. If you do that though, what you will get is 49. Okay. So again, if you have a fraction that's being multiplied by your variable, multiply both sides by the reciprocal, that will give you the solution. Okay. All right, now we're going to move to some multi-step problems. So these are all one step. It only took you one thing that you had to do to get your answer. Those are going to be the first ones that you'll have to solve in the practice. And then you'll move to the multi-step problems where you'll have to actually do some like combining like terms, something like that. So if we're looking at the first multi-step problem, -4y minus 8 equals -2 times y minus 4. Okay. So for these multi-step problems, I think the first thing that you're going to want to do, the first thing that you're going to want to do is expand them out all the way. So when I say expand them out all the way, I mean distribute or multiply any terms that you can. So in this case here, we have a -2 times y minus 4. We're going to distribute this first. And the reason we want to do that is so that we can figure out if we can combine some like terms, where those terms are. So this will leave us -2y, -2 times -4 is a +8. On this side, we still have -4y minus 8. So remember, in order to solve, you need to get all your variables on one side, all of your other numbers on the other side. So we have a -4y here, we have a -2y here. This is just strategy-wise. There's multiple ways you can solve it. I think the easier way is to make your variable have a positive coefficient. So we would want to add 4y first. And again, there's multiple ways you can do this. So this isn't, necessarily one right way, but I think it's the easier way. This would leave us with 2y plus 8 equals -8. So if we moved all of our variables to the right, then that means we'll move all these numbers to the left. The opposite of addition, plus 6, or plus 8 is minus 8. All right. Negative 8 minus 8 is negative 16. And then on this side, we have 2y. So then the last step is going to be divide both sides by 2, because that's the inverse of multiplication. We divide by 2, divide by 2, and we get, I'll write it over here, y equals negative 8. Okay, so again, important things to remember here. First thing that you want to do is expand out any terms that you can, so multiply these things out. After you've multiplied them out, then you need to get all your variables on one side and all your other constants and numbers on the other side. So like I said, it's a matter of preference, but I think it's easier if you make your variable positive. We would add the 4y over to here, subtract the 8 over to there, and we get our final answer. All right, last problem. Ooh, this last one, this involves the single most important math tool you can use in college. Promise you. And I'm not just talking about in a math class. I'm talking about in like a chemistry class, in a physics class. I mean, any class where you're having to do, even nursing, where you're having to solve equations or input numbers, things like that. The single most important strategy you can use if you have ratios is cross multiplication. Okay. So this problem, we've got 5 over 8 equals u plus 4 over 9. Okay, so the first thing that you need to think of is that this u plus 4, it's a term. Okay, so think of it like it's a locked in thing. It's all together. It's one thing together. It's u plus 4. Okay. So then the next thing that we can do, and like I said, this is something that you will be able to do, you know, a lot. You'll use this strategy a lot, is cross multiply. So when I say cross multiply, I mean you take the numerator of one of your ratios and you multiply it by the denominator of the other ratio. So we have 5 times 9, and then you set that equal to the same thing, but the other way around. So we have the denominator of the one ratio times the numerator of the other one. So is equal to 8 times this u plus 4 term. And now you have an equation that's really, really easy to solve. It was difficult. This is not easy to solve. This is easy to solve. 5 times 9, that's 45, equals, we distribute here, 8u plus 32. And then it's just a matter of subtracting and then dividing. So minus 32 minus 32, you get 8u equals 13. And then divide by 8, u equals 13 over 8. Okay, so like I said, cross multiplication, where you multiply the numerator times the denominator and the denominator times the numerator, and you set them equal to each other, is such an important concept. Okay, and then an example, another example, you can see it, you had like x over 2 equals 3 over 4. And you need to figure that out like really, really quick. Bam, cross multiplication could help you with that. All right, so again, just remember, like, these things all review, but they're all really important because they will show up on like that admissions test that you're going to take, or not admissions test, but the placement test for math.